It's time to begin. We've got 45 minutes and plenty of material to cover. So let me begin by saying thank you guys for being here. I know that your time is very precious and you have a choice. You have chosen to spend some time with me and the Groovy ecosystem. I hope that you continue to enjoy the conference. We still have one more day to go. There's plenty of information. Now, some of the projects that we'll see today will be covered tomorrow, and some of them were already covered today. So if there's something that really excites you about the stuff that we're going to see today, just ask me questions, see if we can get that information sorted out. All right, I really like to have this, try to make these discussions a little bit more lively, so that whenever you have a question, just let me know, we will answer. All right? Okay, so without any further ado, the Groovy ecosystem is my Twitter handle. Please be careful, don't. Thank you. This is my Twitter handle in case that you want to get in touch with me. I work for a company called Canoe in Switzerland. Though this being in Spain, I must say that I also speak Spanish. I'm a native English Spanish speaker. Wow. Because I come from Mexico. And I really like spending time in Switzerland. It's a really fun country to live in. There's plenty of chocolate and lots of mountains to see. Be careful with the door, please. I'm the current leader of the Griffin framework, which is one of the projects that we will see today. And I'm one of the few Java champions that actively champion something else besides Java, in this case Groovy. So JVM, Java Platform Champion. There you go, Russell. Alright, enough of me. So, I suppose most of you recognize this reference. Who hasn't seen this picture, this movie? Not? No. Okay, well, because there's going to be a spoiler, and don't come back complaining if you don't know this. So the usual suspects, these are the projects that function like the gateway drug for people to get into Groovy. Now, on the origin, it was Grails, because lots of people wanted to create web applications, and Rails since 2005 was perhaps the best framework outside of Java to do so. So then came Rails. And now we have Gradle, the build system, which I'm very happy to say that has supplanted Rails as the gateway drug. Now more people are getting into Groovy thanks to Gradle. I would like to think that Griffin is also one of the ways for people to get into, but I know that desktop application development is not as sexy or high as web apps. And finally, we got a Spock. That is not the Spock logo. Despite what Johan said, there is now an official Spock logo, and I'll let you to choose if it's the right one. Please be careful with the door. This is the official Spock logo. This versus that. If you don't like it, please tell Peter Nidvise that he should change the logo. Anyway, but you notice that the fifth guy doesn't have a logo. Actually, there is another project that is related to this, and now you know who that guy is, right? Okay, you'll see that in a moment. So let's talk about Grails. I'm going to out in a limb here and say that nobody in this room has not heard or has not used Grails. Is that correct? See? Grails is everywhere. It's been a long time, it has evolved, and in the last few, what was it, last week? They made the release for 3.0, which is a revamp of the framework, and it has let go finally of the old legacy ways of having its own build tool based on Gantt. For a while, Gantt was very good, but if you compare Gantt and Gradle, Gradle gives you more things. So that's what they have done. Basically, they threw away the old build system, built something on top of Gradle, and added more stuff. And they also base themselves in a Spring Boot, which opens the door to create applications that are not specifically tied to servlets or HTTP or something else. Like everybody these days is talking about micro web services. It's up to you to decide if a Grails application that is built with these technologies can be thought as a micro web service, because there are a lot of dependencies. The default set of dependencies is close to 20 megabytes. So I don't know. It is small enough, but perhaps could be thinner. Anyway, so you guys know this one. So I guess there's not much point in me going into these details. Now, Gradle. Is there anybody here that has to suffer the beast? Not anymore. Yes. You know who the beast is. You know who I'm talking about. I'm talking about Maven. The one tool that shall not be named. No, just kidding aside, Maven is fine because it gave us conventions. It gave us better ways to build besides Ant. But Maven is already is close to a teenager now. We all were teenagers once. Some of you may have teenager kids, or you will soon have teenager kids. You know how that goes. So Maven is like that. Gradle is definitely a much better way to build. It's not because it has a Groovy DSL. That is not the point. It's not a Groovy versus XML. It is the fact that Gradle has a much saner object model, has a much richer object model, so that when you define what your project needs, is much closer to what actually your project requires, instead of just the Maven way, one standard way. The happy path in Maven works as long as you stay inside the happy path. But the moment that you step away, even if just 1 centimeter, you're lost. So that doesn't really happen with Gradle. It can be better. It is a perfectible tool. The documentation is superb. It can also be perfected. And personally speaking, creating plugins and extensions for this tool is much, much easier than doing it for the other ones. And the community, as well as the rest of the Groovy community, is very open. So oftentimes, whenever you find yourself in a pickle, just reach out to the Gradle forum or send a message to Twitter to one of the Gradle people, and they will reply very soon. Okay, so now we come to Groovy. In that, I guess there are only a few people that actually have the need to write a desktop application for work. I'm one of them. And I happen to have some stickers in case that you want stickers. Limited edition, actually. And so Griffon builds on the ideas of Rails, because what we found out a few years ago, and it's actually close to 7 years now, so Griffon is quite mature, is that it's very easy to build web applications with Rails. And it's very easy actually to build a web application with any kind of framework. But when you switch into the desktop, what do you use? That's a toolkit. That's not a framework. And that's the problem. There are not really that many frameworks. And even if they were, which they are, the way that they work is completely different to how the web frameworks work. So that all the knowledge that you have from the web is thrown away, and you have to start afresh. So what we wanted to do with this framework is to try to leverage all the knowledge, or as much as possible, the knowledge that you already have from the web, and apply to the desktop. So in the early days, Griffon was actually a fork of the Grails code base. We took the HTTP and HTML things and just kicked it away, put in Swing, and that was it. Over the years, the thing has matured and supports more toolkits, but the basic idea is still there. If you know Grails, finding your way in Griffon is very, very simple. We used to have our own build tool. Now we don't have it, not even like Grails 3. We just either use Maven, this, or, much better, we use Gradle. So there's no need for an IDE tool, nothing specific, no specific IDE plugin. If you use Gradle, just use that. If you use Maven, just use the other one. Much easier. Now, funny picture for you guys. I totally agree with this. Once you switch to Spot, you don't go back. Now again, the discussion whether what should be the official logo. This is definitely not an official logo. This is an image from somebody else. There should be a copyright notice somewhere there. Now Spock. Who doesn't know Spock? Yes, a few hands. Okay, so Spock is a cross between a testing framework and a testing DSL. It's a much easier way for you to define how tests are done, because you can use first the Groovy syntax, which is more concise, is terser than the Java syntax, it's not that verbose. But if this were the only thing that allows you to do, then what's the point? I mean, you just use Groovy. Well, actually, what you do in Spock is that you have defined specific blocks, something inspired by behavioral development. So you have a set of blocks for a given. Then this is where you define your preconditions. Then there is an execution or stimulus. Stimuli in this case, it will be the then block. And finally, where the assertions happens, this is the when block or a spec, depending on what you're doing. So you have the 3 steps, perfect. There's also a cleanup phase where you can let go of any resources in case that you're not only using a Spock for unit testing, but also for integration or functional testing. But there's one more thing that Spock does, which is data-driven tests. Oftentimes, I'm pretty sure that you have found a case for a unit test where you need to test out a method or a series of methods with different arguments, trying out different corner cases. Now, the first thing we do, and that's the thing that I do before I discovered Spock, was using the lowest level of refactor possible. Copy and paste. Copy my method, change the arguments. Copy the next method, change the arguments. Now, so this is the problem, that the name of the testing method has to be updated, and then there's a lot of repetition. There is an argument over there whether your production code should be very dry, but your code may sometimes be wet. I completely forgot what wet stands for, but it's an acronym that really has a meaning.
Write everything twice.
Write everything twice. Close to it, maybe. Yeah. So it's okay to have some kind of repetition in your tests, but it's definitely wrong to just have copy paste all over the place. So you need to parameterize your test. There is a way in JUnit 4.11, if I'm not mistaken, or even 4.10, which is very late in the game for parameterizing your test, and it's very verbose. There's another project out there called JUnit Params that makes it better, but it's not the best. And that's where Spock comes in. Spock allows you to define data tables. You can even define iterators. You can define anything that implements the iteratable interface can be used as a data source for a test. So if you have an I/O bound test, for example, you have to consume data coming from a database, make sure that you wrap it into an iterator, supply it in the expect block, and boom. There's nothing else that you need to be done. All your methods are going to be executed with different arguments. And that's it. It definitely makes the work much more concise. And in terms of IDE support, because this has to be, I think I have an example for this. Let's see, a Spock test somewhere. You will excuse me if I start to show a lot of stuff related to Griffon. There is a reason why I chose Griffon, not just because it's my passion, but many projects of the Groovy ecosystem leverage one another. Let's see, maybe this one? Yeah, that's a perfect example. It's a huge data table. And the formatting idea, it doesn't matter how you screw up this thing, just to apply auto format, and all these things are going to get aligned. No other IDE can do that. And well, if you unroll, then this method will have all these placeholders replaced with the right values. So when you see the reports, you know exactly which iteration succeeded and which one failed. Much, much better than the one that JUnit supports. And, well, there are a few other things that we can say about mocking and interactions, but I believe that data driven test cases are the reason to choose Spark. Everything else is just gravy on top. Now, remember the usual suspects? There was a guy that didn't have a logo. This is the guy. GVM is the Kaiser Sose of the Groovy ecosystem. He is the one in charge. He is the one that allows you to install the other guys. It's easy to download Grails or download Gradle, configure your path, and then get to Dorm. And then when a new version of Gradle comes in, then you have to download it again, add your dust pattern, do every one of these tasks for all of the other projects. Well, GVM takes care of that. Very easy. You just do GVM, install Gradle, fetches the last version. If it asks you if you want to make it a default one or not, you say yes, of course. Then there's a new version coming up. Gradle, GVM install Gradle version, whatever, then you do. If you need to switch back to another version, you just simply say GVM use Gradle, the previous version that you have installed. If it's not, it's going to install it and set it. It just works. It actually works on Windows, as long as you use Sequin.
There's a Posh GVM now as well.
And it also works in PowerShell.
Yeah.
If you use a same built-in environment, and by that same I mean not Windows, you're covered. If you're unlucky to be forced to use Windows, then do yourself a service and install Sequin or PowerShell, and then now you can use GVM. It's very simple to use. It's very small, and Marco has done a tremendous work just to make sure that all projects can push new versions, and he doesn't have to be constantly updating the server side of GVM. It just happens. It's just magic. It's all Groovy, man. That's why I love the Groovy community. All right. So, okay. So now let's look a little bit about web frameworks. Yes, I know the Rails is there, but then we have these other ones. For those of you that are familiar with Google App Engine, and we know we have Gallic. This can be seen as a very lightweight framework on top of the Google App Engine services. There is the brother is called Kelef. It's the same kind of stuff, but it works only in Cloud Foundry. The creator of this framework is Guillaume Laforge, and he is also the creator of this one. That's why the name is very similar. Now he's no longer attached to any of these two projects. He has other stuff to take care of. I mean, he is the leader of the Groovy community, so there are plenty of stuff to go around. These two projects have had recent releases. They're quite stable, and so if you need to create applications targeting those two specific environments, know that you can do some Groovy stuff. Glide is it's a framework that sits on top of Gallic, and this gives you conventions. Glide can be seen as the Grails for Google App Engine, whereas Google App Engine is just the building blocks, the assembly for the web framework. And finally, we got Redpack, which is a re-implementation of something we call micro web frameworks. You might have heard of Sinatra in the Ruby world. And the reason why it's called Redpack is because Sinatra used to be part of a band, well, not exactly a band, a group of artists known as Redpack. Whereas the Scala people, they are very, very witty with their names, and they call their clone Escalatra. Anyway, Luke Daly, the author of he created Jeff, but he also, well, he works for Grailware, so he knows it's straight. He took over Redpack and he recreated the whole thing. It has a Java 100% core written in Java, with a nice coating of Groovy on top. So if you really need to, you can create a really tiny web application with just plain Java. But if you want to have the full power of Groovy, just use the Groovy DSL and you're up to go. Redpack has created a lot of buzz in the last year or so. And I have heard that some Grails people got a little bit nervous about losing ground to Redpack. The problem or the advantage with Redpack is that it's a framework for hipsters, which means if you want to use a very specific database, then you just bring it in and put it in. Whereas in Grails, you have already a full stack framework. There are some choices, of course. You can put any kind of plugin that you want, as long as the plugin exists. In this case, it's just as simple as add a Java class, put it in well, Ratpack uses Google Juice for dependency injection. So as long as there's something that can be injected via Juice, you're good to go. So this is more closely related to the way that you build application thinking in Legos, whereas Grails is a much more bigger and assembled thing. So your mileage may vary. You can use both to build web applications. So again, one's more closely related to hipsters maybe, the other not so much. Now let's talk some about libraries. G-Contracts. I don't think G-Contracts has a logo, otherwise I would have seen it here. But anyway, G-Contracts is one of those libraries that makes you think, how on earth did the author make it possible? Because what G-Contracts is doing is making sure that you can define preconditions, postconditions, and invariants on a class. So pretty much it enables design by contract. If you ever had Eiffel MD, because you couldn't do design by contract in Java or in Groovy, now you can. You use this library. Now I'm showing, yeah, this is a not self-contained script, but what I'm showing here is a class definition where we have an invariant. So no matter how many method calls we make to this class, this has to be true. And by the way, this is something that Johan mentioned this morning, is that this thing here is a closure and is seen as a value on an annotation. This is definitely something that cannot be done in Java. Not even with Java 8, you cannot apply a lambda expression as a value of an annotation. But Groovy, being Groovy, allows you to do this kind of stuff. Now, this method has a precondition and a postcondition. We don't know what the accelerate method does, but at least we know that the current state, you cannot call this unless the engine is already running. And whatever this thing does, it makes sure that the old speed is less than the current speed. This example is related to the fatal accident of the Ariane 5, which we were told that if they had done design by contract, then the rocket would have succeeded with its mission. So that's what we had there. Then we got GPAS. I don't think there's much that I can say about GPAS because we have here Mr. Russell Winder, a core member of the GPAS project. But if you ever have the need, and most likely you have the need to deal with concurrency problems, then GPAS should be your option. It contains actors, which are not a silver bullet, are just one of the many options at your disposal. It contains data flows, CSP, and even software transaction, STM, software transaction memory, which is very high and well known in Clojure. It has some other stuff, and what is great about GPAS is that it comes bundled with every standard Groovy distribution, so you don't have to do anything at all just to use it. Just it's already there in the class path. Russell has posted a lot of examples. He has his slides and code available in many places, and he's not the only one. Dirk Koenig, Baslab, and there are who's the other guy? Alex, and there's the fifth guy, the guy related to CSP, if I'm not mistaken.
John Carriage.
Yes. There are plenty of examples around the web, and there's a good chunk of documentation for GPAS, so you will not be alone.
And if anybody's a CSS expert who wants to fix the GPAS website, that URL's gone, or should have gone.
Yeah, we're switching.
It's www.gpars.org, and it's a mess.
Yeah, so we need you to help us make GPAS better and any other Groovy related projects. We also have this guy, Groovy Effects. Again, going back to the desktop, Sun decided to push a new toolkit back in 2007 called JavaFX. It's very likely that you guys care about this. They pushed a new language called JavaFX script. 2 years later, it tanked because it was really bad. That's my personal impression. And now they rewrote the whole thing as a plain Java library, and that enabled us to write a nice Groovy abstraction on top of JavaFX. And this is exactly what GroovyFX is. It's a nice DSL for creating JavaFX applications. It works with Java 8 and JavaFX 8, but there are a few things that we would like to make better. And the only way that we can make them better is that if we have feedback from people. So if you want to write applications with JavaFX and you want to give a try to GroovyFX, we'll really appreciate if you tell us what works for you, what didn't, and what things we can do better. Now we got GroovyStream. I really like this library, and this library was created before JDK 8 came out. The idea is to provide stream-like capabilities, or generators as they are called in Python. Infinite collections, unbound collections. And it is written as a Groovy module extension. If you didn't know this, there is a feature coming in Groovy 2 called Groovy module extensions, which allows you to add new capabilities at compile time. So it's part of the compile time metaprogramming. These extensions can be type checked and statically compiled, and it's just as easy as defining a metadata file, which we'll see in a moment how we can generate those things very easily. And once you do, then you have access to new classes just because you are there in the class file. So this string class is not the JDK 8 string class. It's a different package. And you can create strings in various ways. You can say from a couple of ranges, or in this case it's actually a map with different values, or you can say from 1, and this will be an infinite list of number 1, or you can define your rules, you can filter them up, and finally apply map. Now, what I believe is the case is that these instructions are not lazily evaluated as is in the case in the JDK 8 stream. When you define this, because it looks very similar to JDK 8, but when you apply filter, map, and the other operations in JDK 8, they're actually recorded instructions but not executed until we got a terminal operator. In this case, collect, or for each, or reduce. In the case of Groovy streams, this will iterate over the string once, and then it will do it twice. So there is a catch, no lazy evaluation. But it's quite useful. Then we got another thing related to streams. So there's one guy that is a friend of Tim. His name is Dinko from is this Slovenia or Slovakia? Or Croatia. It's one of those. I think he's from Croatia. Doesn't matter. He found out about Groovy Stream and decided to create Groovy SQL Stream. So stream capabilities for consuming JDBC results. So this is a Groovy SQL object that can be enhanced with a with stream. So this will be a SQL statement. Now you got a stream that wraps around a result set, and you can do this. Now the difference between Groovy Stream and Groovy SQL Stream is that these instructions are lazily evaluated. So you're not iterating over your data many times, just once. That is pretty good. Some tools. I remember that I said something about the meta files. Well, here are a couple of, and yes, mea culpa, if this doesn't work, it's because I screwed up. I'm the author of these two, one with J and the other with G. The idea was to make a wordplay of service provider interface. In some context, this is a bad word. So don't pay attention. Now, this is Java and the other is Groovy. I don't care if somebody misinterprets this word for something that shouldn't be. So what these projects do is you put an annotation on a file, on a source file. For example, let's see, a good example would be, actually not there, this one. This annotation, artifact provided for. What this annotation does for me is generate a metadata file inside meta-inf, and in this case on the artifact one, which is specific to Groovy, on meta-inf/services/ the name of the interface, and the content will be the class name. So if you wanted to define something that goes in meta-inf services by default, this would be, if I'm not mistaken, service provider for, which I have in, where is it? It's in the juice project? I think so, yes. This one. So that annotation will generate meta-inf services, injector factory, and contain this full class name. And I don't have to do anything other than just compile my code. Now the project with J does it for Java, and the project just uses the annotation processor tool, and the code and the one with G does it with Groovy AST transformations. And it's extensible. So it not only can generate the meta-inf services file, but you can change the format to do whatever you want. So with either of these tools, somebody could write an annotation that can generate the metadata file that is required for module extensions to work, which have to follow a specific format, which is not the one for the services file. We still got Gantt. I don't think there is a major Groovy project that relies on Gantt, but there are still a few legacy there. Gint still does it. Gint is for integration testing.
Yes, very good. I'll actually use it a lot.
Right. Basically is Groovier end, take away the ugly XML, use a Groovy DSL, plus some meta additions, meta programming, and boom, this is precisely what Gantt is. So because it's end, you can build anything you want to. The problem is that every time that you need to build something else, you have to copy over and start again. So that's why we have Gradle, because it has conventions. But we also have Gmaven Plus. There have been, I kid you not, like 4 different versions of Maven support for Groovy. Gmaven Plus is the last one, and so far is the best one. It allows you to do 2 things. One, it compiles Groovy code inside your Maven build, and it also allows you to write Groovy DSL inside your XML. So you don't put it in. So there is a block of XML, and then inside you put the script, and this script will be called as part of your build. So no longer you have to create an AND file and call it using the AND run plugin in order to do something that Maven cannot do. You simply slap in Jmaven Plus, put a Groovy script, boom, you're done. Or better yet, you do Gradle in it, and then you switch to Gradle. ECB? Yeah, there was.
Does this play along with the Polyglot Maven plugin, where you can write your prompts in Groovy?
Yes. So Polyglot Maven, Maven 3 allows you to write your POM files in different languages, Ruby and Groovy. This removes the XML craft, but it doesn't take away the problem, the fundamental problem that Maven has a constraint lifecycle that cannot be changed, and the object model is not as rich as the Gradle one. So it takes away one problem, which is not really the big problem. ECB. Sadly, this project it pretty much reaches maturity. It never released 1.0. It stayed in 0.98. It's quite stable, but it's no longer actually actively maintained because a Spock can also do mini. So what we have here is a script that allows you to define behavior-driven development in such a way that you have mixed in the text that you will write with the stakeholder or the business analyst and the code that fulfills those requirements. The nice thing about ECB is that when you run this, you get two reports. One is the textual report that contains all these descriptions, and the other report that is useful to us developers that contains the times and which ones fail. Actually, you can combine all these things. You can have bigger scenarios, and one scenario that is a precondition of another one, so you can have all kind of combinations. It's a sad thing that I say, it's no longer maintained, but it's quite mature. Then we also have CodeNarc. Who here uses checkstyle for or PND for Java code? Only a few hands. Well, CodeNarc is a combination of checkstyle and PND for Groovy. If somebody told you that it was impossible to write a static code analysis for a dynamic language, he was actually lying to you. It's not impossible, it's hard. But these guys made it, and they did it using AST transformations. And there are plenty of rules that you can configure. There are a lot of stuff that you can do with CodeNarc. And it's part of the standard code quality plugin that comes from the Gradle build. So it's actually a core plugin, so you don't have to install anything else, just configure CodeNarc and boom, you're done. I highly recommend having a look at this one. There will be times where some of the rules may be too stringent or too strict for you, just disable them or configure what they need to be done. Then we got Jeff. I don't know if we will have a specific talk on Jeff, but what Jeff does is, again, it's another kind of like a Groovy DSL on top of WebDriver, which is the next generation of Selenium. So this is pretty much a Jeff script. You can combine it with any framework that you want. It might become the standard for Rails in the future, but it's definitely the standard for Ratback, just because, look, Dali is the one that started this project. It defines a jQuery-like API. This is still Groovy code, but it looks like jQuery. And it also supports, I don't know, I don't see here the page object concept, where you just define how to locate elements in your HTML using queries like this, so that reusing those objects becomes much easier. If you are into testing for at least creating functional testing web development and you haven't looked at Jeff, I highly recommend you. And the documentation is also pretty good. I think they might have switched to ASCII-Doc already. Many Groovy projects are switching for ASCII-Doc as documentation. Now we got GroovyServe. It's another very interesting tool. I don't know which came first, either the Gradle daemon or GroovyServe. Yeah. So what GroovyServe does is kickstart JVM in the background that it's already warm, and once you issue a call using the Groovy client, then the response is going to be faster and faster, because you no longer have to pay the price of starting a JVM every single time. So with GroovyServe paired up with the add grab annotation, you can actually replace pretty much every single Unix script, because you only have to pay the price for starting a JVM once. And all the dependencies are self-contained inside the script, right? Of course, I'm joking, you cannot replace all the Unix scripts, but you can attempt to do so. It's getting rid of those ugly parallel scripts that nobody understands, actually called ASCII poems, as I like to call them, and use this thing. Joking aside, if you have to run Groovy scripts over and over and over again, definitely give a try to GroovyServe. It will save you a lot of time, specifically in CI environments or some other automated environments where running scripts is a constant.
Can we use also with custom application that run on top of Groovy, or just with Groovy scripts?
It only makes sense to kickstart a background application, a background JVM, when you expect to have a lot of hits. You could build it, you can build an application that can leverage a background JVM, but that's not the case for GroovyServe. Okay. It's not embeddable in this case.
Okay.
And then we got lazy bones. This is the official logo now. Lazy Bones started as a frustration for Peter Ledbrook that Ratpack will never have scaffolding, will never have a way for you to bootstrap a project in a certain way. So pretty much it will never have the capability that Maven has for Maven archetypes. So what Lazy Bones gives you is that capability. For any kind of project, for any kind of build tool, with Lazy Bones, you can create projects that target Gradle, or that target Maven, or both, or neither, or anything else. You just simply have to create a template, publish it into a specific place, and then use the Lazy Bones project command line, which happens to be installable via GVM, and up you go. As a matter of fact, all the Groovy, all the Griffon projects that you can create now, because we have again switched from having a custom command to having none, we leverage Lazy Bones. So starting a new Griffon project is, first you have to have Lazy Bones, then you configure the templates, create the application, boom, you go. It's very easy. It's likely, and I don't quote me on this, that Grails could go in the same direction to leverage Lazy Bones for you to create any kind of application. Then we have Crash. Crash is the embeddable shell for any kind of JVM application, and it's here because it uses Groovy for building and executing any kind of command that you want. It comes in with a predefined set of commands like cat and hello and pipe, something like this, but you can create your own commands. And I believe there is a Crash plugin for Grails, so you just do as I think it will be good enough for you to secure shell into the server that's running Grails. As long as you have the plugin, just make sure that the connection to that shell is secure. Then you go inside, and now you can do whatever you want inside your application. As long as you have commands, you have access to the class path, you have all the libraries. Just be merry and do whatever you want with your application. We got GrooveScript, which there's going to be a talk tomorrow by the author, Jorge Franco. GrooveScript is a transpiler. It is a combination of a translator and a compiler. It translates Groovy code into JavaScript code, because everybody's doing JavaScript these days. And Jeff Atwood's law is that if something can be written in JavaScript, it's going to be written in JavaScript. So there you go. Publishing tools. We're almost done. JBake is here because of two reasons. One, because I love ASCII Doctor, but also because JBake is a publishing tool that accepts Groovy server pages as a templating system. You can also use FrameMaker or TinyLeaf, and it will, in the future, will support Cedric's new Groovy template engine, which is using the Groovy documentation website. It's a statically compiled, builder-like templating engine, which is very concise, and it's pretty cool. We use JBake for the Griffon website, and it's used for Cedric's blog, and it might have been something to do with the Groovy documentation. We also got Grain. Oh, JBake is installable via GVM. Grain, which is a static website generator that also supports ASCII Doc. I believe it's also supported in GVM. It's not?
No.
Okay, so sad for them. And we got Gaiden from the same guys that bring you Groovy set. These are a couple of guys in Japan. Gaiden is also a static web generator, but it uses Markdown. And it's installable via GVM. So regardless of whether you're into the Markdown camp or the ASCII Doctor camp, there are still options for you to create well-behaved and beautiful documentation. The future. So what's coming up later with different projects? Well, I leave you with this quote from Cedric. If Netflix, which is a huge multinational company, can invest in Groovy and pretty much build most of its core business around a dynamic language. It's very likely that the organizations and the companies you are working for, are working with, can also leverage this language and these projects. Netflix makes extensive use of Gradle, excuse me, Gradle, Ratback, Grails, and Groovy itself. They make a lot of tests with a Spock too. So if they can do it, we certainly can do it too. I like the fact that many of the projects in the Groovy ecosystem rely on one another. Many of the projects you saw here are actually built using Gradle. So whenever Gradleware pushes a new release and something breaks, we give them feedback very fast. Or, well, Spock was pretty stable, so that would be a bad example that somebody broke Spock. But we make use of many interesting tricks in a Spock. We use Ratback or JBake as our publishing tools. Again, something gets broken, then we tell them and they fix it. So the Groovy community is very open, very helpful. I think this is all that I have for you now. So again, let me remind you, tomorrow there are more talks. There are more, some of the content that you saw today is going to be covered with much more detail tomorrow. There are a lot there are plenty of speakers that you can talk to, and some of the speakers attending the conference are also the project leads or are involved in this project. So don't lose your chance to talk to these people. Any questions?
About the documentation components you just saw there. Components, you know, as Doctor or Markdown. There are, I mean, like light frameworks, or could you use it beside Grails?
So the three ones that we saw, JBake, Grains, and Gated, what they do is actually they produce a static website. So because of that, you just zip it up and put it on a web server, and then you're done. You can and you may combine a static aspect of these websites with a dynamic aspect. In this case, you may use Ratback or Grails. In the case of the Griffon website, we just got everything statically generated. We use the Gradle plugin to because there's a JBake Gradle plugin, so that you can run the documentation, and once everything is generated, we use the Git Gradle plugin to push it to GitHub pages, and it's done. Just a single command line in Gradle, and everything happens. That's what I love about the Gradle commands. Everything works most of the time seamlessly. It's not a perfect tool, it's perfectible. Any other remarks? Questions? No? Again, thank you very much for your time, and keep enjoying the conference. Don't forget the stickers.